let's just start off by what is physics? So physics describes the interactions of energy, matter, space, and time. It deals with the very large, like galaxies up at the top left here, down to the very small of individual atoms, the stuff that makes up all of the materials and different objects around us. So it spans this very large scale. Simply put, physics describes why the things around us happen the way they do. And so you may not know any physics or think you know any physics, but really we all have these experiences that we've lived. We've seen things happen around us a certain way. So I encourage you throughout this course to bring in all of those experiences. You know, we've seen these things happen. And so as we're going through the concepts within all these learning modules, think back to experiences that you have. Why, if you've ever wondered why something happened the way it did, start to relate it to these concepts. I guess a word of caution I have with that is sometimes with this physics description, it may be different than what you thought was the reason why the thing happened. And so there may be some disconnect between how we describe things formally in physics and how we talk about them in everyday language. But nonetheless, bringing in these experiences, whether they are correct or incorrect from a physics standpoint, will help you visualize and make things more concrete when we're dealing with these concepts. So since physics describes all of these everyday interactions, some of these things have recently happened, like the launch of the SpaceX rocket. Physics describes why if I'm using my phone, I need to have a certain kind of glove to be able to get it to respond. It also describes why my phone even responds to my touch at all. And then it deals with probably less interesting things, but why on-ramps and off-ramps have different speed limits. What determines why that speed limit's there and why it even matters? And so physics can give you that description, and we'll be doing stuff that explains some of these things. So moving on, I'm sure a lot of you are going to be coming from different educational backgrounds, so your field is not going to be physics, I assume. But if you look closely, the fingerprints from physics can be seen in all of these different areas. So with chemistry, chemistry deals with the interactions of different atoms and different molecules. Well, physics is what describes those interactions. Chemistry deals with those processes, but physics describes the interactions. With biology, we have how animals are moving, whether it's on the land, in the sky, in the water. Physics describes that motion. And more applied areas with athletic training or physical therapy, how joints are moving or how your limbs are moving, the stress on certain bones, those things can be described from a physics standpoint. And then with engineering, the development of new technologies, how we're getting faster phones, how we're getting better resolution cameras, how our TVs are getting higher resolution and more energy efficient. All of these things are being driven by principles in physics. And then the building of pretty much all of the infrastructure is rooted in the laws of physics. How are these things going to behave over time is going to be described using physics. And then with geology and environmental science, the idea of energy and energy consumption and climate change, those things are described using physics, which directly impacts those fields. So for all these different fields, you can trace back components to physics and how physics can apply to these different fields. So one thing that I encourage you to do throughout this course is to think about what your field of study is and how these concepts in physics can relate. Or if you have questions about it, reach out and we'll try and make that connection to make things more concrete and make it more applicable to what you hope to do moving forward. And so now we're going to hop into Module 0. The learning objectives for Module 0 are listed here. In all of these intro videos, I'm going to be listing these learning objectives because I think it's useful. At the end of the module, I encourage you to go back and look through these and ask yourself, when you're done this module, am I able to explain what physics is? Am I able to describe some applications of physics? And so if your answer is a kind of, or I have no idea, then you should go back to the note packet or the textbook and look. And if you're still unsure and you didn't just need a refresher on it, then you should reach out, come to my office hours or email me to make sure that you know all of these things, because all of these concepts build on one another in physics. So if you don't have this base foundation right, if you're missing a few bricks here and there, as we start piling those bricks on, it could leave for a shaky foundation. So I really do encourage you to use these learning objectives. They're there to guide you in your review for exams, review for quizzes, because this is where we're choosing the problems from. It's based off of these abilities. So I encourage you to look back at these. They're going to be on the module page, but they're also going to be within these videos. So units that we're going to be dealing with in physics, we're primarily going to be working in SI units, or the International Standard of Units. And so those are comprised of 4 fundamental base units, which are dealing with length, mass, time, and electric current. And so length has units of meters, mass has units of kilograms, time has units of seconds, and electric current, which we're not going to be dealing with in this course, is units of amperes, or amps for short. And so from these base units, all of the other units that we're going to be dealing with can be written in terms of these base units. So a couple examples of that would be speed. Speed is a measure of length over change in length over change in time. So it's going to have units of meters divided by seconds, which is the fundamental units for length and time. And then this idea of force, if I'm pushing on something, we're going to get to this later on, but this has units of newtons. But newtons, which is a derived unit, can be written in terms of kilograms, meters, and seconds. So all of these derived units can be boiled down to in this case, 3 fundamental units that we'll be using in this course. And so another type of thing that we'll use is this idea of prefixes. So prefixes allow you to give a scale to your number, really. So really big, for computers, you may have heard gigabytes or megabytes. And really that is just a measure of how many bytes. So with mega, it's 10 to the 6 bytes. Or giga, it's 10 to the 9th bytes. So it's a lot of bytes. And then if you go down with centimeters or millimeters, we've heard of those things before. And so that is, 10 to the minus 2 meters. Millimeters, which is 10 to the minus 3 millimeters. So those are smaller than the just single unit of 1. And then it keeps going down. So the example I have here is this image of a human hair. So if you take a hair out of your head, if you look at the width of the hair is about 10 micrometers, or 10 times 10 to the minus 6 meters. So it's a pretty small width. And so these prefixes are things you might see in the wording of problems. So it's just another way to write out a numerical value. And so here's an example. I'm going to flip around my computer to write on it. And so here's an example of a unit conversion problem and an approximation problem, which are both listed within the learning goals. And so the question that we were asked is, how many heartbeats are there in a lifetime? And that's the only information that you're given. So this is where the approximating comes into play. So the question is can we approximate something about how many heartbeats there are? And so the first step that I did was to come up with an approximation. And so I chose the approximation to be there's 100 heartbeats in a minute. And so that's probably a little high for a resting heart rate, but I chose that to just kind of make the math easier. Again, you could choose 70 heartbeats per minute. It really doesn't matter all that much as long as you're within some sort of ballpark range. You know, you wouldn't choose 10 heartbeats per minute. I don't think that person is probably alive at that point. So 100 heartbeats per minute is the approximation. So that is how we're going to get this problem started and how we're going to build off of it. The next step is we need to know the heartbeats in terms of a lifetime. So we've got it started on some sort of framework for heartbeats. Now we need to get it in terms of a lifetime. And so this is where unit conversion comes into. So the first step is to convert minutes into hours. So that's 1 hour is 60 minutes. So minutes up top and minutes down below cancel each other. And then from hours, we want to get into a day. That's 24 hours is 1 day. So hours cancel up top and down below. And then from day, we want to get to a year. So 1 year is 365 days. So we have days down below and days up top. So those cancel. And then finally we reach, so these were unit conversions. And then finally we reach the last spot going from a year to a lifetime. So a lifetime is not a standard measure. So this is again another spot to approximate. And what I chose was 70 years would equal a lifetime. Of course, there's much less and much longer, but 70 seems like the right range and is probably pretty close to what the standard US lifetime is right about now. So years cancel up top and down below. And ultimately, we're left with 1 times 10 to the 9th heartbeats in a lifetime. And that ends up being what we were asked. We're asked how many heartbeats there are in a lifetime. And so we use unit conversion and approximations to be able to answer that question. So this skill of approximating values is something that you're going to be able to practice more throughout this course, and it's going to serve you when solving physics problems.